Hey everyone, back for another lesson on the periodic table. So today, as I promised last day, we're going to look at patterns in the periodic table. And I've already mentioned that the periodic table is arranged in a certain way. Last day we were introduced to the staircase here. Review: everything over on the left of the staircase is a metal. Everything on the right is a non-metal, except for this little guy here, hydrogen. And I'll begin to explain why he's out of place in today's lesson. So the periodic table is arranged so all elements in the same column have similar physical and chemical properties. So the periodic table, we look at it in terms of columns. So here's a column, here's a column, here's a column. Columns run up and down. We will also be looking at rows, which run across, but rows are less important than columns. So each column, we call this a chemical family or a group. And uh, just to explain, so it says here that periodic tables are arranged so all elements have similar physical and chemical properties. And then if we think of it in terms of family, so I want you to think of your own family. Your family quite often looks the same and acts the same. And I know right now you're thinking of your younger brother or sister and you're kind of shuddering and saying, no way, but it's true. Within our families, there's definitely a resemblance among family members. We all have some common feature. Maybe you have your dad's eyes, your grandmother's nose, whatever it might be. So let's agree that family members do look somewhat the same, but family members often act somewhat the same as well. So maybe you walk the same way as your dad, or you have a same mannerism as your mom, or perhaps sometimes you say something, or you have an expression that you say, and other people in your family use that as well. So families often look the same. Families also act the same, and it's the same thing with these chemical families as well. So within these chemical families, these are elements that look the same and act the same. And that's why they're in these families. That's why hydrogen's over here. In this case, it doesn't look like any of these other alkali metals in this family here, in this column, but it acts the same as them. In this case, acting the same is more important than looking the same. But over here in this family, we'll be looking at this a little bit later. These all look the same and they act the same. Likewise, in our halogen family here, these all look the same to some degree, but they definitely act the same. So acting is more important than looking. So we also call these a group. It's a vertical column of elements, and they're labeled from left to right. Now there's this periodic table, I picked it because there's two different numbering systems. You'll see here, this is column 1, column 2, and we go all the way across to column 18. In grade 9, we're not so worried about the column 1 through 18. If you did print off a periodic table, I'm going to ask you to label the families this way. If we were in class, I would give you a paper copy and I would have you at this point relabel them. This column here, we would relabel as column 1. And you can kind of see that up here that it does have a 1A. This here would be column 2. We would skip over the transition metals and we would label this family here with boron at the top as 3, and you can see it is labeled right here as 3A. Carbon, this column or family would be 4. Nitrogen, this column would be 5. Under the O, or for oxygen, 6, 7, and 8. So I would have you renumber these: 1, 2, 3, 4, 5, 6, 7, 8. And going forward, we'll be referring to them as those columns as well. All these blue in the middle here, these are transition metals. We don't deal with those in grade 9. As well, we have these two series down here, and they would actually be they fit right into this spot of the periodic table. All these green ones here, they would be actually stacked on top of each other like a deck of cards, and they go into this spot. Likewise with these red ones, these scarlet ones, they would be stacked on top of each other, and they would go into this spot. So chemical family, we've gone over that. We've gone over a group. A period is a fancy term for a row. So with potassium here, this is a row. We also have other rows up here as well. And you may notice that the periodic table is kind of weirdly shaped up here. The reason is no elements fit into these spaces. And I'll talk about that a little bit later too. So we're going to look at 4 families or 4 groups today. The first group is family number 1 right here. These are called alkali metals. So we have hydrogen, lithium, sodium, potassium, rubidium, cesium, and francium. So alkali metals, they're in group 1. They look the same. They are soft, shiny, and silver. We'll probably do a lab with these ones later. This is one of my favorite labs because I actually show you a couple chemical reactions with some of these elements. And when I say soft and silvery and shiny, lithium, sodium, and potassium, I actually show you in the lab. I do an experiment with you, and I can cut these with a butter knife. So we're talking soft. Lithium with a butter knife, I have to put quite a bit of pressure on it to get through the piece. But by the time I get to sodium, it's easier. And they get softer as we move down. Potassium is like a hot knife through butter. So it is a metal. It is very shiny, very silvery, but very soft as well. Kind of like cutting through a piece of Play-Doh. So those are alkali metals. Soft, silver, shiny, they look the same. They also act the same, and this is why they're in that family. They're very reactive, especially with oxygen. They react right away. So in this lab, if I was to cut the lithium, if I had a piece of lithium, it would be white on the outside because it's reacted with the oxygen, and it actually gets a tarnish on the outside, so it's white. And when I cut it in half with that butter knife and break the 2 pieces in half, you can see that it's shiny and silver. But right before your eyes, you'll actually see that white tarnish start to form again. It's reacting with the oxygen very, very fast, and it tarnishes over. Within 5-6 seconds, it's tarnished over already. So you can't see that it's shiny inside. You'd have to recut it to see the inside again. So that's what we mean by fast. And in nature, you very rarely find these elements on their own because they do react with other things. So in nature, you won't find sodium on its own. It's reacted with oxygen or it's reacted with other things. So to get sodium on its own, you would have to break that compound into. So we talked about table salt, a lot of salt in the Earth's crust and in the oceans. Salt is sodium and chlorine. If you were to break that table salt down back into its 2 elements, then you could get sodium. And so here is that family, a little bit of a YouTube video for you to watch here as well. And hydrogen is the one that's not a metal. It's not shiny, it's not silvery. It's sort of like the adopted member of the family because it reacts very, very fast, especially with oxygen, like the rest of the family here. Our second family, this purple one here, this is our alkaline earth metals. So the first family was alkali. Second family is alkaline earth metals. And like their neighbors, they are shiny and silver, but they're not as soft. Can't cut these with a butter knife. But they are very reactive, but not as reactive as the alkali metals. And they're kind of neat. We do a lab sometimes called the flame test, where we actually make compounds containing these metals and we burn them. So what I would do is I would take magnesium or calcium, mix it with some water, make a solution. We would dip popsicle sticks in them, get them nice and wet, and we'd hold those over a Bunsen burner. And they would change the color of the flame. So we get purple flames and green flames and red flames and bright orange flames and yellow flames. So we get different color flames based on these. So that's what that's talking about. They burn with brightly colored flames. Now, you'll notice on next to this this family here, it says increasing reactivity going down. So I would also, on your periodic table, have you label this up. On the metal side, things get more reactive as we go down. So lithium is reactive, very reactive. Sodium is even more reactive, faster and more violent, so to speak. Potassium, okay, reacts even faster and it's more violent, more of a reaction. Rubidium, cesium, and francium. And when we get to this lab, you'll see like in the lab, I would do the reaction in front of you with lithium, sodium, and potassium. And rubidium and cesium, we not even allowed to store it in the school. These are far too reactive, and francium doesn't even exist. And it exists as a compound in which it's stable, but scientists will not even take francium and try to separate it from its compound because it's too unstable and too dangerous to work with. It's so reactive. So on this side, I would draw an arrow going down showing that things get more reactive. Likewise, in our alkaline earth metals, beryllium is very reactive, but the least reactive, the magnesium, calcium, right down to radium here, they become more reactive as you move down the family. They react faster and much more violently. The next family that we're going to flip over to, I believe, is family 8 here. These are our noble gases. Now, this periodic table doesn't show it, but at room temperature, which is 20 degrees Celsius, normally these letters are color coordinated. So all the black letters would be, at room temperature, a solid. And the vast majority of the periodic table is a solid at room temperature. Only 2 are a liquid at room temperature, and that is mercury and chlorine. And the rest of them, or I shouldn't say the rest of them, and some of these are gases at room temperature. And that is right here. Our noble gases are all gases at room temperature. So in this case, this family looks like each other. So these are noble gases. These are group 8. They are very stable and unreactive. So unlike on the other side of the periodic table, the alkali metals, these are very stable. They don't react with things. And they are gases, as I mentioned. And the kind of neat thing about them is when you run electricity through them, you get they glow. And we're familiar with these in neon signs. Neon signs don't have just neon in them. They have helium and argon and krypton and xenon. And you can see the different colors that they glow when electricity's passed through them. All right, I'm noticing that I'm running out of time here on my video, so I'm going to pause it and get a second video going, which should be a short one.